Hey, Tim DeStasio here. It is again Psychrometric Saturday. Now, we have been talking a lot about enthalpy in the last few weeks. Enthalpy is another word for heat. And there are two types, sensible heat and latent heat. And when you add sensible plus latent heat, you get total heat. And that is what this scale here is, the enthalpy scale. That is just an extension of the wet bulb line. And we read our enthalpy. And so it's important for us to know what our entering and our leaving enthalpy is, and that's going to tell us what our total heat that our air conditioning system is removing. But if we want to take it a step further and understand what the percentage of sensible versus latent heat that make up that total heat is, we can do a very simple procedure, and the psychrometric chart is great for visualizing. So we have 2 points that we applied last week. 75-degree dry bulb, 55-degree dew point is our return air, and 55-degree dry bulb, 50-degree dew point is our supply air. So typical textbook settings between supply and return air temperature and moisture. So let's plot that first point, 75-degree dry bulb. We come across the dry bulb scale. We find 75, halfway between 70 and 80, and then we go up on our dew point scale until we intersect with 55, which is halfway between our 50 and our 60 line. So here is our operating point. If we want to know what that enthalpy is, then we draw a line that intersects our operating point and runs parallel to these wet bulb lines, and we just extend it into our enthalpy scale. So we're reading somewhere around 28.1 BTUs per pound of return air enthalpy. Now, what is our supply air conditions? Well, 55-degree dry bulb, 50-degree dew point. So 55-degree dry bulb, we go up here until we reach the 50-degree dew point, really close to the saturation curve, but we go ahead and plot a dot there, and then we run a line that intersects that dot, but also runs exactly parallel to our wet bulb lines. We extend that line into our enthalpy scale, and we get 21.5 BTUs per pound of supply enthalpy. So what's the difference? What's the total heat that we're removing out of there? Well, if we subtract 28.1 minus 21.5, we get 6.6 BTUs per pound of dry air. But out of that 6.6 BTUs per pound, how much of that is sensible and how much of that is latent? Well, here's a really simple procedure that the psychrometric scale makes very, very easy for us to visualize. So the first thing that we're going to want to do is determine what is the difference in our dew point, because we're separating the dry heat from the moisture heat, the sensible heat from the latent heat. So here's what we're going to do. We're going to simply take our entering dew point, which was 55, and we're just going to draw a line straight down until we intersect our leaving dew point, which was 50. And so we have another dot here. And what that dot represents is the demarcation point between sensible heat and latent heat. So if we draw another line through here that intersects that new dot, runs parallel with our wet bulb lines, now we have two zones. We have a fat zone and a skinny zone. The skinny zone is going to be our latent heat, because this is the difference in grains per pound of moisture or dew point. So this little skinny zone right here is our latent heat, and this fatter zone here, whatever is left, has to be our sensible heat. So how many BTUs per pound did we remove of latent heat? Well, we have to subtract our entering enthalpy from that latent heat enthalpy, and that is right around 26.3 BTUs per pound. So here's what we do with that. We have to subtract that 26.3 from our starting BTUs, which is 28.1. We come up with 1.8 BTUs of latent heat. And so out of this 6.6, 1.8 of it is latent. That means that the rest of it has to be sensible. So all we have to do is subtract 1.8 from 6.6, and we find out what our sensible heat is. When we subtract 1.8 from 6.6, we come up with 4.8 BTUs of sensible heat. So out of our 6.6 BTUs per pound of total heat, 4.8 was sensible, 1.8 was latent. So next week, we're going to actually take it a step further, and we're going to talk about sensible heat factor, which is the ratio of sensible heat to total heat, which tells us a lot about the performance of our air conditioning system. But for now, we're going to leave it off. Thanks for joining me here on Psychrometric Saturday.